Here is a relatively easy, simple example of the centripetal force. I have a turntable of some sort turning in this direction. This is sort of a 45-degree angle looking down at it. The platter is spinning in this direction, shown by the arrow, and there's a mass sitting on this table, and it has a gravitational force of mg. There is friction, namely mu mg, because the force of friction is equal to mu times the normal force, and the normal force is mg. So here's the force of friction, and that provides the centripetal force. The friction provides mv squared over r. And velocity would be its velocity as it spins. The faster we spin it, the faster the velocity, and we'll get into how that relates to angular velocity as we do more complicated problems. But what causes the centripetal force in this example? Friction does. The mass is canceled. By the way, this is why when you go around a curve on an exit or entrance ramp on a highway, it doesn't say trucks more than 10,000 pounds travel at this speed, small cars travel at this speed. Because mass falls out of the equation. V squared over r is mu g, and the maximum velocity that you can have in a turn before you slip is mu rg. On a flat surface, it is a square root relationship, the square root of mu at times the radius of curvature times g tells you when you will start to slip. So there is the maximum velocity possible for a spinning object held only by the friction force caused by the normal force of gravity as this object spins. So that's your introduction to a relatively straightforward problem on centripetal forces.